What's up, class? We're going to look at properties of logarithms today, section 7.4. Properties of logarithms, section 7.4. And you know what else we're going to do? Properties of logarithms. We're going to find some in section 7.4. Awesome. So let's get to it. The first thing I want to do is think about logarithms are the inverse of exponentials. You switch to the x and the y, and you do that. And that's really what we talked about in the last section. It's kind of weird stuff, right? It's the first time you ever did stuff like this. But I'm sure the first time they told you that 3 plus 4 was 7, you thought that was weird too. So it's just a matter of what? Practice. So let's practice. First thing I want to do is look at a couple of old rules that we had that dealt with exponents, and we're going to invert them. So x squared times x to the third is x to the fifth. And I'm going to leave a little space there because I want to write something. And then I'm going to say x to the fifth over x to the third gave me x to the second. So I kind of wrote this basically the same numbers in a couple different ways. So when we're dealing with exponents, when we're multiplying the bases, we add the exponents. Multiplying the bases turned into adding the exponents. And dividing the bases, the terms, dividing the bases became subtraction. 5 minus 3 gave me 2. So those are a couple of rules that you had before. What we're going to do, we're going to invert these, okay? So we're going to start by adding some logarithms. So let's say log 2 plus log 3. But we also have to invert what we do then. The addition becomes multiplication of those numbers. So this is log 6. And you can punch that in your calculator. If you take log 2 plus log 3 gives you log 6. And you can just straight up do that because these are all log base 10. So over here, the x, we kept the x the same. The base stayed the same. So over here, the base, log base b, log base 10, 10, 10. That stays the same. Okay, maybe that's left side worthy. And we'll say the addition over here becomes multiplication. Here, division became subtraction, so now we're going to invert this. We're going to start with the subtraction problem. Oh, I don't know, let's say log 6 minus log 3. And subtraction, this is the inverse. Instead of division becoming subtraction, subtraction is going to become division. So 6 divided by 3 gives me 2. So subtraction becomes division. Whoops. Okay, so those are a couple of rules we're going to have and use. One other thing I want to look at, let me change color here. What does 3 log x mean then? So if I said, what is 3 log x? Well, remember that 3 times something means you add it that many times. Like 3 times 10 means 10 plus 10 plus 10. So this means log x plus log x plus log x. Well, up here, we discover that addition becomes multiplication. So if I multiply all of those together, that gives me x to the third power. Let me copy this down here as well. So if 3 log x is x to the third power, we're going to have another rule here. The coefficient becomes the exponent. Whoops, I need to write log. Sorry about that. I had to squeeze it there. So the coefficient becomes an exponent. Okay, we have a formula I'm going to share with you next. We had some bases. If you look in your calculator, it just has log base 10, and that's not always what we want. We have different bases, so this is the change of base formula. And it's really easy, as long as you remember what to do. Okay, so let's try to think about what is log base 2 of 7. Well, what you need to do, I can't type this directly into the TI-83, and it's not something I can do mentally either. 2 to some power gives me 7. That's madness. That's like a decimal, because 2 to the second power is 4, and 2 to the third power is 8, and that's not a 4 or 8, and it's in between. So somewhere between 2 and 3, because 2 squared is 4, 2 to the third is 8. So to find out what it is, the change of base formula says just do this. Take the log of 7 over the log of 2. And that's it. Just type it in. So let's see here. Log of 7 divided by log of 2 and 2.8. And that should be close to 3, right? 2 to the third power is 8. So 2 to something close to 3 is going to give me 7. So that comes out to 2.807, 2.81. If they don't go evenly, they'll be disgusting. They'll never be pretty. They'll never be a nice fraction like, 1/2. Well, maybe they'll be 1/2. But these are usually going to be disgusting. Blech. Okay, last thing. And this is really just review. This is nothing new. I just want to make sure when you see something like x to the -1 power, that means 1 over x. When you see something like the square root of x, that means x to the 1/2. And when you see something like the 7th root of x, that means x to the 1/7 power. These are our fractional exponent or negative exponent rules, and you need to keep them in mind. So always keep these stowed away in your heart. Make sure when you see a 1/2 power, you have to think in your head a square root, and when you see a square root, you have to think in your head the 1/2 power. This one's incredibly important. Very important. Very important. Very important. Very important. Beautiful. And those are your notes for section 7.4.